Okay, welcome everyone. We're just getting everyone in from the waiting room. Thank you for your patience. As we get everyone in, I'm gonna just begin our introduction so we can get started right away. So hello and welcome to episode 9. We're almost done with the series for this season. I'm Lindsay Randall, the host of the speaker series, and Digging In is a series of live presentations with scholars from around the country, and today internationally, co-sponsored by the Robert S. Peabody Institute of Archaeology and Massachusetts Archaeological Society. We're going to begin with a land acknowledgement for the land that the Peabody Institute and its school, Phillips Academy, are on. So Phillips Academy occupies the land of the Pennacook and Patuxet people and the lands of the contemporary Abenaki, Massachusetts, Wampanoag, Wabanaki, Pokanoket, and Nipmuc nations. We honor all Indigenous people who are here now, have been here for time immemorial, and will be here in the future. And we acknowledge Indigenous genocide and the continued oppression of Native peoples, voices, cultures, and spiritualities. We understand how education has been used by settler institutions and the attempted erasure of Indigenous peoples. And we commit to interrogating the histories of and our complicity in colonization, centering Native voices and communities, and dismantling the ongoing legacies of settler colonialism at Phillips Academy and beyond. So join us every other Wednesday, Eastern Standard Time through June. We really only have one more episode left for the season. And for the schedule of dates and presenters, you can check out the peabody.andover.edu or the Massachusetts Archaeological Society's Facebook page. And if you are enjoying our programming, consider expanding your impact by becoming a member of the Massachusetts Archaeological Society. We are able to bring you outstanding programming through support of viewers like you. And today we are very excited to welcome Dr. Moutsiou. Dr. Theodora Moursiou is a postdoctoral researcher at the Archaeological Research Unit at the Department of History and the Archaeology in the University of Cyprus, as well as an adjunct senior research fellow at James Cook University of Australia and the Max Planck Institute for the Science of Human History. Dr. Moutsiou holds a PhD in Paleolithic archaeology from the Royal Holloway University of London and a master's with distinction in the archaeology of human origins from the University of Southampton and a BA with distinction in history and archaeology from the Aristotle University of Thessaloniki. I'm sorry, I can't pronounce that one. Her field experience is the study of prehistoric movement, mobility, and exchange through the analysis of raw material, circulation, and selection. And she combines traditional archaeological methods such as excavation, survey, lithic analysis with cutting-edge approaches such as geochemistry, geospatial analysis, paleoecology to address major research questions in human cognitive and behavioral evolution. And while she extensively publishes about her research and presents at national and international conferences for experts, she also takes steps in connecting with the broader community, inspiring children and young adults to engage with archaeology and science more generally. And during and at the conclusion of the talk, viewers are able to submit questions directly to me via the Q&A function or at the chat function at the bottom of your Zoom screen. And then we'll give our speaker time to answer as many questions as they can, with the understanding we might not get to all of them. So welcome, Dr. Moutsiou, and thank you for joining us today.
Well, thank you for inviting me, Lindsay, and thank you to everyone who's here watching us. And I wanted to thank you a lot for organizing all of this. It took a little bit of planning, but I'm really happy to participate and actually to have this opportunity to interact with colleagues from the other side of the pond. So for my talk today, I actually want to concentrate on the Eastern Mediterranean. And I would like to discuss social interactions between groups geographically separated by sea and the influence of such water gaps in the scale of prehistoric connectivity. So I will begin with a brief overview, very brief overview of the deep history of the region and its connection with the sea, before turning my attention to the island of Cyprus to explore its maritime links to the mainland from the terminal Pleistocene to the late Aceramic Neolithic. Oops, I should probably share my screen. Right? Okay. Is that working? And
yes, now it is. Perfect.
Yes, perfect. So just to position us in the region, my main area is going to be the island of Cyprus. You can see it here circled with light blue, which is surrounded by the Levant to the east, Anatolia, so modern day Turkey to the north, mainland Greece with the Aegean and Ionian seas to the west. Traditional narratives of seascapes regard islands as isolated from the continent, too impoverished to have sustained hunter and gatherer populations, and landscapes to be conquered and tamed by technologically advanced human groups associated with a Neolithic lifestyle. This view of the sea as a barrier to human movement is particularly persistent in Eastern Mediterranean prehistory, with the colonization of the region's islands commonly regarded as a Neolithic phenomenon, initiated by farming populations from the mainland under demographic or environmental pressure at the start of the Holocene. Now, this perception is at odds with recent evidence demonstrating the presence of mobile hunter-gatherer and forager groups on many of the Eastern Mediterranean islands, I'll show you later on, and the surrounding mainland prior to the Holocene. Pleistocene hominins are well known from multiple localities and variable habitats across Western Eurasia, with examples from Israel, Syria, Turkey, Jordan, Lebanon, and as far south as the Arabian Peninsula, with dates starting as early as around 1.4 million years ago. Looking to the west in mainland Greece, early and early Middle Pleistocene sites are very scarce. There is, however, growing evidence for the Pleistocene human presence in the area from the late Middle Pleistocene onwards, so around 5 to 400,000 years ago, with paleanthropological and archaeological remains from sites across the peninsula. Archaeological sites of the Pleistocene age have also recently been documented in the Mediterranean modern-day islands of both the Aegean and Ionian seas, with examples from excavated sites on Lesbos and Naxos, as well as surface lithic finds collected from islands in the Ionian, including Corfu, Lefkas, Kefalonia, and Zakynthos. Now, paleogeographic reconstruction of both the Aegean and the Ionian demonstrate that, in fact, very few of these islands were insular during Pleistocene glacial episodes, when sea levels were sufficiently low to have exposed land bridges that could have been traversed by foot. One exception is the South Aegean island of Crete and its neighboring islet of Gavdos. Now, both of these islands provide strong indications for Pleistocene sea crossings in the Aegean. Crete and Gavdos, like Cyprus that we will see later on, have been disconnected from the mainland for several million years. Claims based on recent archaeological fieldwork put human presence on Crete and Gavdos as early as 130,000 years ago. So, although limited, these examples demonstrate early human ability to adapt to coastal environments and, crucially, to successfully navigate the Mediterranean Sea as early as the late Pleistocene. The technological capacity of early humans for maritime crossings is exemplified in the following period, the Mesolithic, demonstrated with an increase in hunter-gatherer occupation of numerous islands in the Aegean and Ionian, and the first examples of human presence on Cyprus. With the advent of the Neolithic, maritime movement and human engagement with the sea truly intensifies. At this time, the Mediterranean Sea connects insular and mainland communities via long-distance maritime interactions, raw material transports, commodities exchange, and even shared symbolic systems. For example, obsidian transportation between islands in the Aegean, as well as between islands and the mainland, highlights a strong dialectic amongst these Neolithic communities mediated by the sea. Despite clear evidence for the successful early exploitation of insular environments in the rest of the Eastern Mediterranean and other parts of the world, as far back as 100,000 years, Cyprus is still persistently regarded as isolated from regional phenomena and largely unaffected by them. The main reason behind this marginality view is the island's insularity and geographic location at the periphery of the continent, separated by an approximate 70-kilometer sea gap if we consider the closest continental coastline. Moreover, a long-term presence of hunter-gatherer populations on Cyprus is debated on the grounds of presumed limited insular resources and ecological carrying capacity. Notwithstanding the fact that hunter-gatherer populations favored different ecological niches compared to subsequent permanent farming lifeways, the apparent lack of indigenous foragers narrative has been disproven by the documentation of several terminal Pleistocene archaeological sites on the island. So I wanted to talk about the earliest of these sites, dated to around 12,000 years ago, Acroteria Aetokremnos. Aetokremnos is a small collapsed rock shelter with well-defined stratigraphy containing substantial faunal and cultural materials. According to the site's excavator, Alan Simmons, the artifact assemblage comprises of over 1,000 pieces of microlithic and bladelet-oriented chipstone and a small number of ornaments, including picrolite beads. Faunal remains are much more abundant, comprising about 300,000 bones, the majority of which belongs to pygmy hippo, but also includes birds and over 70,000 shells. Since its documentation, a small number of additional early Holocene forager sites has also come to light, such as Nisi Beach, Akamas Aspros on the southern coast of the island, and Vrechia Roudias further inland. Small collections of surface lithic pines collected during field projects from the early 1960s up to the early 1980s, in combination with recent field surveys, provide further support for a potential pre-Holocene exploitation of the island. Although the earliest phase of the island's prehistory remains one of the least well-known, these early examples and a renewed dedicated research focus on the period bring to light new information suggesting familiarity with the sea and use of the medium in human movement in this part of the Eastern Mediterranean from at least 12,000 years ago, if not earlier. Now, the start of the Holocene signifies a more constant use of the sea as a way of life. Maritime pathways were used for the transfer of pigs and other faunal and floral elements to the island. Additional species are introduced via sea routes throughout the Neolithic, while strong parallels between the Cypriot and Levantine material culture in architecture, lithic technologies, and possibly ideology suggest ongoing interactions between the two regions. The initial Aceramic Neolithic sites of Agios Tichonas Klimonas and Agia Varvara as Prokremnos signal the permanent presence of people on the island. These first permanent settlements saw evidence for hunting, plant cultivation, and modest consumption of marine foods, dating to around 10,000 years ago, followed by a settlement expansion in the Middle Holocene around 8,000. The traditional view of Cyprus regards these early settlements as the outcome of Neolithic farmers who arrived from the mainland and subsequently turned their backs to the continent, developing in isolation because of the presumed sea barriers prohibiting communication. So for the rest of my talk, I wish to concentrate on a particular component of the Cypriot archaeological record of the period to discuss how accurate this perception actually is. My focus is on objects made of exotic raw materials as proxies of prehistoric social interaction, long-distance exchange, and communication. I will specifically look into Carnelian and Obsidian, two categories of rare stone objects that provide direct material evidence for tracking long-distance maritime links with the continent. Both raw materials are non-native to Cyprus, with geological sources occurring in various locations in the Circum-Mediterranean region. Carnelian exploitation is primarily known from the Indian subcontinent and mainland Southeast Asia. Near Cyprus, bibliographic references suggest the occurrence of good quality Carnelian sources in Turkey, Armenia, Egypt, Yemen, Saudi Arabia, Iran, Uzbekistan, and Afghanistan, although the precise location and quality of these sources are far from understood. On the other hand, obsidian is much better studied, with outcrops in discrete regions around the world associated with Neolithic volcanic activity. Close to Cyprus, good quality obsidian sources occur in the Aegean islands of Milos, Antiparos, and Yali, as well as in central and southeastern Turkey and the Caucasus region. Carnelian is one of the oldest known gemstones, with a tradition that extends from the Neolithic to the present day in the manufacture of jewelry and seals. It enjoyed widespread popularity, especially in ancient Near East and India, where its attractive red color and brilliancy denoted the material with a high value, second only to lapis lazuli. In Aceramic Neolithic Cyprus, carnelian artifacts are extremely rare and found exclusively in the form of beads, seemingly following the Near Eastern stone bead making tradition. So from the whole of the island, for the whole of the Aceramic Neolithic, we have like 50 beads, that's all. With regards to obsidian, the earliest, although very limited evidence for obsidian use comes from the initial Aceramic Neolithic and the site of Aios Tichonas Klimonas. Here, obsidian occurs in a very small quantity, represented with an assemblage of 3 bladelets and 1 blade. Obsidian use on the island reaches its peak during the early Aceramic Neolithic, and at this time it is distributed across the island in quantities that exceed those of the preceding or following periods. Obsidian consumption declines during the late Aceramic Neolithic. To date, there is no evidence of core production on the island, and the strong technological parallels on the obsidian artifacts we have with those of the Near East suggest that the obsidian tools found on Cyprus were manufactured offshore and subsequently introduced to the island in finished form. Using portable X-ray fluorescence spectrometry, it was possible to geochemically analyze all of these exotic artifacts and determine the occurrence of multiple geological sources in the Cypriot archaeological assemblages. Based on their elemental values, carnelian artifacts that you can see on the left can be separated into 2 distinct groupings, although the lack of sourcing data limits our ability to provide any associations with specific geological sources. As far as obsidian is concerned, at least 3 different sources are represented in the analyzed assemblages. The majority of these artifacts are sourced to the Central Anatolian volcanic complex of Golu Dag, with a lesser amount to Nenezi Dag, also in Central Anatolian source, and also an example, and the first one for Cyprus, an example from the Eastern Anatolian source of Bengal B. You can see the used sources, the yellow asterisks on the map. Now, the provenance of these exotics to various sources in the mainland demonstrate practices associated with seafaring and a more constant and adept use of the sea as a communication tool. Cyprus is an oceanic island separated by open sea since the late Miocene, so for about 6 million years. A sea gap of at least 30 to 60 kilometers will have separated Cyprus from the continental coast during episodes of marine regression. Moreover, although low sea levels will have exposed part of the now submerged extension of the Cape Apostolos Andreas in the form of a short arc of offshore islands, this would not have functioned as stepping stones due to their distance from the mainland coastline, these little red dots that you see on the map. In practical terms, this means that at any stage in Eastern Mediterranean prehistory, people involved in the exchange of Carnelian, Obsidian, and likely other materials and objects will have by default relied on the sea and maritime travel to perform these exchange events. An important question that this discussion raises is why will these early communities choose to get involved in the establishment and maintenance of long-distance exchange networks? Long-distance travel is risky, time and effort consuming, and requires substantial advanced planning, especially where the sea is involved. Therefore, from a cost-effective perspective, the benefits associated with such an undertaking must outweigh these cognitive and organizational costs. Ethnographic and archaeological records around the globe are full of examples of people moving individually and in groups, not only for subsistence purposes, but also for reasons of social contact, including the establishment of new social ties or the reaffirmation of existing ones. Returning to Cyprus, the amounts of obsidian and carnelian indicate that the value of these exotics lies within the realm of their social life. For example, the obsidian quantities reaching Cyprus are too small to identify a specific lithic toolkit, and locally available good quality chert will have been equally, if not more appropriate for most day-to-day activities linked to farming. Moreover, items of personal ornamentation, such as the carnelian beads we saw earlier, could have been used for social display, with the raw material itself having a particular significance in the bearers' lives. Sophisticated information crucial to the operation of a society can be conveyed even through the distribution of everyday objects like stone tools. This is so because in social transactions, the value of portable resources is closely connected to the individuals who perform those actions. Along with the processes of manufacturing, handling, and transporting them, artifacts acquire agency by taking on the properties of the individuals as social actors. The materiality of the objects themselves influences their value, as well as the scale and patterns of their circulation. Objects made of materials that stand out are in fact more efficient in creating and maintaining social relations than items that do not share distinctive physical qualities. Certain visual material qualities heighten human sensory responses because they affect the way they are perceived by the human brain, with some classes of objects attracting a lot more attention and respect than others. The ability to reflect light, color, and brilliance have been found to be aesthetically satisfying and in certain societies, even spiritually charged with power. This innate attraction to objects that are colorful, sparkle, shine, or transmit light appear to elicit aesthetic and even emotional responses that transcend cultural or chronological boundaries. Material objects are active agents in the maintenance of complex social relations that enable individuals to communicate without the necessity of face-to-face interaction, what we call in absentia, and to overcome otherwise inconceivable distances. The selected stone's unique aesthetic properties impute the chosen materials with a symbolic power that extended across land and sea. The symbolic role of obsidian and carnelian artifacts, I argue, is linked to their ability to entangle communities and individuals in emotional bonds, either kinship or alliance relationships, that can be maintained at a distance. These exotic objects function then as symbols of relatedness, as a powerful symbolic medium for those early Cypriot communities' social strategies and negotiation within the changing Mediterranean Neolithic world, possibly even as a buffer against resource stress and the risks associated with frontier colonization. Now, the archaeological record of early Cyprus provides evidence for an active interest on behalf of these early settlers towards a continued two-way interaction with continental communities within the broader Eastern Mediterranean social sphere. This interpretation implies that different Neolithic groups crossed to Cyprus for a variety of reasons rather than an exclusive goal of sedentary farming. For example, Cyprus could have been used for intensive resource exploitation, including pigments, seedstone, raw materials such as picrolite that is ideal for bead making, or even perishable resources such as salt and seaweed, or even fish, shellfish, and marine avifauna that lay near or beyond the shore. A broad and diverse array of material, faunal, and malacological evidence from the late Aceramic Neolithic indicates that the Cypriot communities had not only adapted by this time to a new insular way of life, but also, rather than developing in isolation, they maintained some level of overseas contacts, as seen in the continuing consumption of exotic raw materials, as well as special categories of objects, such as the characteristic incised or decorated dentalium cells that demonstrate not only continuing maritime contacts with the continent, but also perhaps even a shared symbolic or referential world. Throughout the Aceramic Neolithic of Cyprus, Near Eastern-based populations were actively engaged in transferring to the island people, livestock, crops, exotic artifacts, and other goods. Similarly, populations already on the island were exporting locally available resources to the continent, either directly or indirectly. Seafaring increased the range of foragers and expanded their contact with other lands and peoples. Their involvement in the coastal domain enabled them to expand their habitats, giving them access to new resources, material and social, which ultimately led to the creation of a regional maritime interaction sphere. The Mediterranean Sea, far from being an obstacle to these interactions, was in fact a means of connecting people in the exchange of objects, ideas, and genes, serving as a highway to communication, enabling communities to entangle themselves in a web of social relationships that extended across the sea into a truly connected world. And with that, a big thank you, and I think I'm done.
Perfect. Thank you for that. That was awesome. So yeah, so if anyone has any questions, you can type them into the chat or into the Q&A, and I'll read them to Dr. Moutsiou. So first off, I would just like to say elephants in Cyprus. That was so exciting to see. Yes. Learn something new every day. So I'm going to begin. I do have a question. So you talked about like sort of the shell and the faunal that you found. What is the soil like in Cyprus? Like, is the faunal stuff sort of preserved because of the shell? Because I think in New England, our soil is so acidic that you will not find any faunal material unless it's in a shell knitted. So what is the sort of the preservation in Cyprus for that stuff?
Well, what my archaeologist friends tell me is it's really bad. So we also have very acidic soils, so organic preservation is pretty bad. The itokremnos side, I don't know if that was just something crazy happening in the area that preserved the bones, but I think it's one of our largest archaeological collections.
Cool.
Yeah, pygmy hippos, pygmy elephants. Yeah, it's very exciting. We have paleontological sites across the coastline. But yeah, I haven't excavated anything, like any bones. So all I can tell you is what my colleagues tell me.
Hey, no, that's perfect. I just didn't know if, because I know there are certain soils that are good for that stuff. I know ours isn't, so I'm always like, what is someone else's soils, right?
Apparently Cyprus is also one of the worst places.
Okay, nice to know. So we do have a question about sort of environmental changes. So how has sea level rise affected any of the sites you're studying? And have you used any submerged sites maybe in your research?
Right, so submerged. This is a question. I'm very interested in this topic, and I'm actually starting a new project that we are planning on doing some underwater surveys. I know there is, like, for that early prehistory, I know that there's been a study by Ammerman that this Akamas Aspero site that I mentioned, they also did some underwater survey, and apparently they found some lithics. Yeah, definitely. I believe a lot of information is currently underwater, so we need to establish, like, we need to study the bathymetry and to look what happens, reconstruct the coastline so we know exactly where to go.
Yeah, and as current sea level rise affecting any of your sites threatened or anything?
I'm trying to think. Not really the sites that I'm looking at. I mean, they are coastal, as you see on the map, but that's like 5 kilometers from the current.
Okay, so we'll get back to you in 40 years when they're no longer there, right?
Maybe in 10, 50, when I will have discovered my new site. But obviously, if you're looking at the later stuff like Roman, I'm sure there are, yeah, a lot of sites like ports that are affected, and it's not really my period, so I don't have any details on that.
Okay. We have another question. It's a bit of a doozy, so we can kind of do this in different parts. So I think they're referring to your two-way interaction slide. So have you visited any of the Obsidian source sites or looked at any of the archaeology for those source sites? And if so, are there any corresponding Cyprus artifacts found that might show direct exchange with those sourcing Obsidian, or were there middlemen between the sources and Cyprus?
Right, so before I forget, no, I haven't visited actually the Turkish Obsidian sources, but I have visited all the Greek ones, so Milos, Yali, and Antiparos. I've visited those. I have acquired by some very, very kind colleagues some geological samples from the main Turkish sources to use for my geochemical analysis. I don't know of any, if I got that right, Cypriot material on the Obsidian sources.
Yes, I think that's what they mean.
No, I don't know what that would be. I'm thinking that so I'm gonna change a little bit the subject before I forget it.
Yeah.
So across the Near East, like the Levant, we have a lot of these green beads. They're very popular in the Neolithic. And Daniela Bar-Yosef has studied them extensively. And in her view, we don't really have we don't have picrolite in the assemblages. But I wonder if this is actually the case. And we have another project where we're actually trying to geochemically characterize picrolite, so we can then go and analyze some of that material on the mainland to be actually confident in saying, yes, the geochemistry doesn't match, so they're not Cypriot picrolite. And another thing that will require a lot of work is chert. So Cyprus has very, very good quality chert. So I wonder if some of that material was actually being exported. But just by visual, you can't really make any claims. So again, we need geochemistry to be able to say, yes, this is chert from Cyprus. And this work hasn't been done. I mean, chert is very difficult to characterize.
Not only the geochemistry, you need a ton of funding.
Yes, of course.
Right.
So now, as to whether we have middlemen or not, I don't know. We are talking about 3 kilos of obsidian in like 3,000 years for the whole of the island. Most of the sites have like 20 pieces, like one handful. There is Silurocambos on the southern coast that has around 600 pieces, and Acanthu on the northern coast that apparently, I haven't seen the material, has about 5,000 pieces of obsidian. Apparently, there is an idea that the material was being transported from the sources in Turkey to Acanthu, and then from Acanthu distributed on the island. I don't know why that would be the case, or why this is a better scenario than people communicating and interacting
individually,
directly.
kind of thing.
Yeah. I didn't put a map up here in the presentation, but I actually mapped all the sites of the same period that use obsidian across Anatolia and the Levant, and there aren't really any very coastal sites, except for one, I think, in Israel that is on the coast and uses obsidian. And most of the sites are in the Levant rather than Turkey. So I don't know what's happening. I think all scenarios are open. It could be directly, it could be indirectly, but I mean, I don't know what to say. Like I can't say it's one or the other. I think it could be either. I just can't. I don't dismiss the possibility of direct interaction. I don't think it's by default indirect.
Okay. Well, that last doozy was our last question. Oh, no, I think we got another one. Which trace elements were used for the discrimination between different obsidian sources?
So the discrimination was done on rubidium, strontium, zirconium, titanium, and iron. Yes.
Okay. Any other questions? Anyone else? You want to pop it in? If not, thank you, Dr. Moutsiou, for joining us today, and thank you to our viewers. And we look forward to seeing you at our next lecture, which will be on Wednesday, June 1st. And we're going to be joined by Jar Hamilton, who will be speaking about the archaeology of buffalo soldiers. So again, we rely on the support viewers like you, so continue supporting our outreach by becoming a member of the Massachusetts Archaeological Society. Have a wonderful Wednesday, everyone, and have a good night, Dr. Moutsiou. It's 8 p.m. or now probably 9, so.
Fine. And thank you for inviting me, and good luck with everything. And thank you everyone for listening.
So.